Lesson 4-2, horizontal and vertical lines. The big idea is every horizontal line has an equation of the form y equals k, and every vertical line has the form x equals h. Let me show you a picture. A horizontal line is a line that goes through a coordinate plane. This is my x-axis and y-axis. But it goes from left to right. Horizontal means laying down, okay? Every single horizontal line starts with y equals k, or y equals. Why it starts with y equals is because it only goes through the y-axis, okay? And y equals, they say k down here, that's my constant. Well, this has to go through something, so if I said this was 1, 2, 3 right here, so it goes through 3, that means my equation for this horizontal line is y equals 3. Now, much is the same for vertical lines. Okay, here's my coordinate plane. A vertical line is a line that goes up and down. 1, 2, 3. It starts with x equals something. Okay? Vertical is up and down, and it equals whatever it goes through. In this case, it goes through 3. Okay? Notice the difference. Vertical line up and down starts with x equals. Horizontal line going left to right starts with y equals. If you remember from a previous example in our book, I Can Guess Your Age puzzle, they gave us a table starting with the number is our x value, the result is our y value, so they created a table 3, 3, 10, 10, negative 8, negative 8. If you were to graph these points, you get those here. As you can see, this is a linear line that has a slope. How do we know it has a slope? Well, it's increasing from left to right as it goes up. We know this is not a horizontal or vertical line. Okay? This has positive slope. If you look at the 7 is heaven puzzle, okay? This is the puzzle where your result is always 7. You always get 7 out. It doesn't matter what number you put in, you always get out 7. So if you put 3 in, you get out 7. You put 10 in, you get out 7. If you put a negative 1 in, you get out 7. But they graph these points. Notice this is a horizontal line. This is a horizontal line. Horizontal lines start with y equals. And if you notice, if you have points on the line, it's y equals because every single number is the same on the y. Okay? Every single number is the same on the y. So it's y equals 7, because that's the number that it goes through. This is a horizontal line at 7. It says the points lie on a horizontal line. For all these points, the y-coordinate equals 7, as I stated. In short, y equals 7. Okay, horizontal line equals 7. Every horizontal line has an equation of this type. In a horizontal line, slope of the line equals 0. That's important to remember also. So equation of a horizontal line. Every horizontal line has an equation of the form y equals k. You need to write that down, where k is a real number. So as soon as you see a horizontal line, you know it's y equals, and then what you have to find out is where's the k at. So example 1 says, find an equation describing all points on the line graphed at the right. Well, do we have a horizontal line? Yes. Since we have a horizontal line, we know it starts with y equals, okay? And if you want to, you could pick out some points here. negative 1 comma 2, 1 comma 2, and 3 comma 2 are all points that lie on that line. And as you can see, what's all the same? My y's are all the same. Where are my y's the same at? Well, they're the same at 2. So it's a horizontal line going through 2. Equations for vertical lines. A vertical line is drawn at the right. Notice that the x-coordinate of the ordered pairs is 4.5 regardless of the y-coordinate. Thus, an equation for the line is x equals 4.5. This means x is fixed. That means x doesn't move either way. It stays on 4.5. But y could be any single number. So if you notice, if you have a vertical line, all your x values are the same. It doesn't matter what your y-coordinate is. All your x values are the same. So the equation for this vertical line is 4.5. X equals 4.5. The equation of a vertical line says every vertical line has an equation of the form x equals h. So you know it starts with x equals. You just have to find out where the h is of the real number. Example 2 says, A, graph x equals a negative 20 on a number line. B says graph x equals a negative 20 on a coordinate point, or a coordinate plane. So let's do A real quick. Here's our number line. Our point of interest is a negative 20. Well, this only has one solution, right? X equals a negative 20. So we have a closed circle right at a negative 20. We don't go to the right, we don't go to the left because it only equals one thing. On a coordinate plane, we know we're having a vertical line, so it has to go through the x-axis. This is my x-axis. Where's negative 20 at on the x-axis? Well, if this is 0, negative 20 is like right out here. So I need to have a vertical line that goes through a negative 20. Some points that would be on it is negative 20 comma 1, negative 20 comma 10, okay, negative 20 comma negative 2 would also be points that are on that line. So we could plot points right up along here and then connect my dots. And yes, Mr. Johnson's graph's not that great, but you can tell it's a vertical line that goes through a negative 20. Okay? Example 3 says, at the beginning of a vacation, Matt has $900 in his savings account. As long as he has at least $300 in his account, he does not have to pay a service fee. Each morning he withdraws $50 from an ATM for spending money. How many days can he withdraw $50 per day without paying a service fee? Okay, so let's make an equation. What does Matt start with? He starts with $900 in his savings account. He is going to spend $50 every single day. So he is subtracting $50 every day. How do you say every day? Well, that's my variable. That's my x. Okay? As long as he has at least $300 in his account, he does not have to pay a service fee. So as long as it equals, is greater than or equal to 300, he doesn't have to pay a service fee. They want to know when he's going to have to pay a service fee. So as long as it equals 300, we're fine. Okay? So, doing our math. Okay? Two-step process. The inverse of adding 900 is subtracting 900. Whatever I do to one side, I have to do to the other side. My 900s are gone. Leaves me with a negative 50. X is greater than or equal to 300 minus 900 is a negative 600. Okay? Divide by a negative 50. Since I divided by a negative 50, what has my inequality have to do? Well, it has to flip. Okay? So X is now less than or equal to, and 600 divided by 50, a negative 600 divided by a negative 50, negative divided by a negative is going to be positive. 600 divided by 50 is 12. Okay? So, and what I probably should have actually done was put a less than symbol instead of an equals, because here's why. At 12, he's fine. Okay? There's no problems with that. When he gets less than 12 is when he, or when he's less than or equal to 12, he's okay. Okay? So 12 days or more, he's okay. Okay? 12 days or less, sorry. Because if he only took it out 1 day, he's fine. If he took $50 out 2 days, he's fine. Okay? 13 or more, he's in trouble. He gets that fee. Fee applied. Okay? Moving on. Deviation from the mean. For statistical data in a scatter plot, a horizontal line at the mean can help to show how the data relate to the average value. The hourly temperatures in Flagstaff, Arizona on a June day are shown in the graph below. Related to each temperature is its deviation from the mean, which is the difference between the actual temperature and the mean temperature. Okay? This is what I need you to know. Deviation equals actual, that's what you have right now, minus the mean. So we're going to take the actual temperature minus the mean. That's what you do every single time when dealing with deviation. Actual, what you have right now, minus the mean. So let's take a look at that. Okay? Here's our temperature. Okay? All these points across here are temperature readings at certain hours during the day. Okay? If I were to look at this temperature, this is my temperature right now, let's say, at the 10th hour. My temperature right now, let's say it's 76 degrees. So, 76 degrees minus my mean. What was my mean? Well, my mean is 68.1. Okay? My mean is 68.1. So, wow. Meant to put a point, wrote my 1. 68.1 degrees. So, 76 minus 68.1 gives me 7.9 degrees. And what we say that is above normal. Because what's normal is 68.1 degrees throughout the day, right? That's our mean. That's above normal. Okay? So that means all these dots right up through here are going to be above normal. Okay? That means all these dots down here are going to be below. So let's take a look at this. At the third hour, or let's pick an easier one. At the first hour, it is 55 degrees. minus 68.1. We still have the mean. Since you got a bigger number minus the mean, that means you're above normal. You have a smaller number minus the mean, that means you are below normal. So 55 minus 68.1 is a negative 13.1 degrees below normal. And we can tell that it's above or below normal based off of positive or negative. That's all I have for you today. Please enjoy. We'll see you tomorrow.